Okay, back to AP Calculus. We're going to find the area enclosed by the graph of y equals e to the x, y equals x, the y-axis, and the line x is equal to 2. So we can just start with this. I'm going to actually go through this on a calculator a little bit just because I think there are some important parts, but you know what, let's do that first. Okay, that's fine, let's do that. So I'm on a TI cast CX. As long as it's a cast, you're in really good shape. The older ones are just as good, so don't worry. And all I'm going to do here is I'm just going to drop this equation in. So if you go to the button that has the pi sign, it also has e, and we want e to the x is the first equation that we're concerned with. So there's that function right there. And we also wanted y equals x, so you would have hit the tab button to get back to here, and y is equal to x, and then hit enter. And okay, so here's what I want to do. Okay, I'm going to take a look at this for a second, and remember that we also said that it's going to be bounded by the y-axis, right? So if we're going to bound this by the y-axis, then it's bounded here too, isn't it? So I'm going to just draw a picture here. And it's also bounded by the line x is equal to 2. So x is equal to 2, and you can see here that, whoops, just if you can pretend that I went right through that point right there, okay? So we're looking for this area, and we're looking for the area in here, aren't we? Because we want the bounded area, and we have to believe that somewhere here this thing closes up, doesn't it? Okay, so this is the area that we're looking for. What was important to me is we can see that in this whole area that we're interested in, in every place that we're interested in, this part of the function, right, the e to the x power, is over this, right? It's going to come in really handy in just a second. So let's take a look. All right, so this is what we're going to do. We're going to take this thing, right? We're going to write this out this way. We were told that we wanted this function. We wanted the area. If you think about this, from 0 to 2, right? Well, how do we know? Because this is the y-axis right here, right? Here's the y-axis, and it says it's also bounded by a line x is equal to 2. And we drew that out, didn't we? And also we looked, and we found that e to the x power was over the other function in every place, right? So we had y equals e to the x, and we had y is equal to x, right? Let me do this better. E to the x. E to the x power. We realized that this one is over this one at all times. So look, I set these things equal to each other. This is the algebra that I'm doing. Setting them equal to each other, right? And then figure out which one is higher than the other one on the interval you're looking for and subtract the opposite one. So I'm going to get e to the x power minus x is equal to 0. And all I'm doing is making a composite function here. So here's my composite function. I just wanted you to see where I got it from, right? And from here, we can just start our integration, I think. So the next thing I want to do is integrate. So I'm going to go ahead and do that. I'm going to integrate here. And it's really important that you know the rules of integration. This, remember, this e to the x here is one of the strange ones, that the integral of e to the x is e to the x. But the integral of x is this negative sign, is this one, isn't it? And then remember what we did is we had x to the first over 1, didn't we? We added 1 to this and added 1 to that, so we'd get x squared over 2, right? And then we have to say that we're going to evaluate this from 0 to 2. And if you want to, you can enclose this like this. It does not matter one bit. And then from here, we're going to use the fundamental theorem of calculus, right? Which tells us if we take f of b minus f of a, we'll find that area, won't we? So that's what I'm going to start to do now. I'm going to go ahead and evaluate. So what did we do so far? We looked at the graphs. We figured out which one is over the other one, which one is higher on the interval we're interested in, and we subtracted one from the other to get this composite function here, right? We integrated, and now we're going to go ahead and evaluate. So I'm going to evaluate this, and we're going to take f of 2 minus f of 0, right? F of 2. F of 2 would be e to the second minus 2 squared is 4 over 2, right? 4 over 2 is just 2, right? 2. This negative sign is this one. and f of 0 now. What is f of 0? Well, 0 squared over 2 is 0, but what is x to the 0 power is just 1, isn't it? So far, so good? And then we're going to get, our solution will be e squared minus 3. Please remember, e is a number, right? It's Euler's number. And we know that it's 2.7, God, I can't, 71, something like that, and it goes on and on forever. And there's a formula that helps us figure that out. But remember that e is not a variable. It's a constant value, isn't it? So here's our solution. All right, I hope that was helpful. Good work.